Welcome back. We are now getting into 1.7, so transformations of functions. So the first transformation is just moving it. So we're not really changing and not stretching it or distorting it in any way. We're just moving it in all the four directions, not three, four. So let's take a look at how we can do that. So the first thing is what's the fancy name for shifting those graphs around? And those are called translations. So we're just moving it in one of the four directions. Now how we do that is simply by adding and subtracting in the right spots within the function itself. So we have to be a little bit careful how we do this. So we got our vertical and horizontal shifts. So a vertical shift up and down is pretty logical in what happens to the function. You can kind of see that if we're using C as our units, our number of units, we're just going to add and subtract that on to the end of the function itself. So whatever function it is, we're just going to add those units or subtract those units from the end, and that will shift it up and down. Left and right, or horizontal, is a little bit different and a little bit awkward or backwards from what you might think. So when we're shifting it to the right, we're actually going to be subtracting it inside of the function. So we're modifying the value of x itself and subtracting c from it. That moves it to the right c units. And then if we add those c units to the value of x, it's going to shift it to the left. So you're going to see it a little bit easier once you have some examples, but just keep in mind that it's backwards for horizontal shifts. Subtraction moves it to the right, addition moves it to the left. So be careful. All right, so let's take a look at a few examples. So they want you to compare the given graph with the graph of f of x equals x squared. So we got our standard parabola. It's normally centered at the origin. So what are we doing to it? So in this case here, we're just adding 5 to that x squared function. So we're adding it to the end. So we should be able to quickly determine that this is just going up 5. We don't need to get too fancy with right sentences. We're just quickly just describing what's going on. For this one, okay, we got that minus 3, but look at where it's located. Is it affecting the overall function itself or just the value of x? And you can see that this one's just affecting the value of x. So now we got that minus 3, so we know that's a horizontal shift, but be careful, it's a shift to the right. So right 3 units should be what happens to that one. And now, what do you think for this last one? So now there's two things going on. We do have x being affected by this plus 1, but there's also a minus 4 at the end. So that minus 4 at the end is going to do what? It's going to make it go down 4, but the plus 1 inside is going to make it have to go to the left 1. So again, all you're doing is taking that parent graph, that parent parabola, and just, shifting it up or down, left or right. All right, let's try another style of question. Find the equation of the graph if it is a transformation of x cubed. F of x equals x cubed. Now, it's a little hard to see it in here, but that's an ordered pair of 0, 1. So it just looks like it's been shifted up 1 unit. So we can just add that 1 to the end. And that's it. There's our new equation of that transformation. So what about this next one? Now again, the ordered pair is a little hard to see, but this ordered pair right here says 2, 1. Now be careful. Do we really care about this point that's not really the center of the graph? It's just some point that's on the curve to kind of help you out. The point we really care about is this one, where the graph kind of goes up and then it curves up again. I'm doing it backwards, but So we can kind of see it does, and we want that center point. That's the one we want to focus on. So what's happened to it? It normally passes through the origin, and now it's shifted to the right 1 unit. So what should be our function? Y equals x plus 1 cubed. There's my buzzer. Hopefully you got that right. It's not plus 1, it's a minus. Because it's shifted to the right, it's backwards, remember. All right, what about this last one? Same kind of trick going on. They're giving you this point down here, which it's hard to read, but it's -1, -2. Do we care about that point? No. All we care about is this one. And we can see that it's shifted down 1 unit from where we normally would start at. So we just need to subtract 1 from the end. All right. Now, so we have those different layers of problems that we can see, but we also have domain and range that gets altered when we transform our functions. So we have to look at that sometimes as well. So we have our square root function. So again, put that in your mind. It normally starts at the origin. It kind of hooks its way to the right. So what's happened to this graph? What's happened to this function? What's that +2 do? Is it on the end, or is it affecting the x? And hopefully you're saying it's affecting the x. And because it's a +2, that means it's to the left. So what does that mean about the domain and range? So if the domain is shifted to the left 2, it normally starts at 0. So where do we start the domain? Should be starting at -2 now. And we want to include -2, so we want that square bracket. What about the range? Well, the range, remember, is the y values. Do the y values get affected because we shifted the graph left 2? No. So the range doesn't change. It still is going to be 0 to infinity. Okay, so now let's go to this next one. So what can you tell me about the transformations for this? There's 2 of them. The -3 affects the value of x, so that means it's horizontal. So we know it's going to go to the right 3, and then the +1 is at the end, so it's also going to go up 1. So now we have to think about the domain and range. So for the domain, what's the domain of absolute value back in 1.6? That parent function, remember, it's a v. Just because we're shifting it left or right, does the domain actually change? No, because it's all real numbers. So we can just put that in. But what about the range? So again, the range is focused at the origin. So the left and right doesn't really make a difference, but it does go up 1 unit. So because it goes up 1 unit, the range can't start at 0 now. It's got to start at 1 and go to infinity. And we want to still include that 1. So, okay. So there's the first taste of transformations. We're going to see some more types of transformations in the next videos. So see you in the next ones.